factor the difference of two perfect squares. Notice in the first example, x squared minus 64. X squared is considered a perfect square. Its exponent is 2, and 64 is a perfect square. So this will factor as x plus 8 times x minus 8. Notice I took the square root of the first term, x squared, and I took the square root of 64, 8. Notice that it has two factors. One has an addition sign and one a subtraction sign. If you FOIL these, you will see when you multiply the inners and the outers and add them together, they will add up to 0. That's why this first term is a binomial. Take a look at the second term example. 4x squared is a perfect square because 4 is perfect and x squared is perfect. It has an even exponent. 36y squared is also perfect, so it will factor as the difference of two perfect squares. 2x plus 6y times 2x minus 6y. Notice 2x and 6y are the same in both factors, but one factor has an addition sign and one factor has a subtraction sign. Let's look at a second example where we have to apply the technique more than once. Y to the fourth minus 1. Y to the fourth is perfect because its exponent is even, and 1 is a perfect square. So this is going to factor into y squared plus 1 times y squared minus 1. Take a look because we're not quite finished. Y squared plus 1 can't be factored any further, but y squared minus 1 is once again the difference of two perfect squares. So I can factor it into y plus 1 times y minus 1. In the third example, we're going to apply several techniques to factor it. It's 4 terms, so at some point you know we'll be grouping, but notice before you begin that 5 is a factor of all of the terms. So let's factor the 5 out of every term, and it results in x cubed plus 3x squared minus 1x, or x minus 3. Now I have 4 terms, so I'm going to factor by grouping. I'll put my parentheses around them. Notice there's a subtraction sign, so that will change the sign of the second number. And when I go to factor it, I'll write down the 5 that I've already factored out, and then I will factor out the GCF from the first term, which is x squared times x plus 3 minus, and in this term, if I want, I can write the 1 times x plus 3. Now my GCF is an x plus 3 times x squared minus 1. Do you notice anything? X squared minus 1 can be factored further. And so my final answer is going to be 5 times x plus 3 times x squared minus 1 is the difference of two perfect squares. X plus 1 times x minus 1.